Hello dear friends and welcome. Today I am going to deliver a lecture on information networks. First of all, let me highlight the objectives of today's deliberation. First, we will learn about information networks in general. We will try to explain the concept of computer and computer programs. We will try to understand Internet, World Wide Web, browsers and EMBnet. And finally, we will talk about SRS, NCBI, HTTP, HTML and other URLs. To begin with, let me first of all give you a general idea about information networks. The past decade has seen a convergence of social and technological networks with systems such as the World Wide Web, characterized by the interplay between rich information content, the millions of individuals and organizations who create it, and the technology that supports it. A computer network or data network is a telecommunications network which allows computers to exchange data. In computer networks, networked computing devices exchange data with each other along network links, that is, data connections. The connections between nodes are established using either cable media or wireless media. The best known computer network is the Internet. Network computer devices that originate, route and terminate the data are called network nodes. Nodes can include hosts such as personal computers, phones, servers, as well as networking hardware. Two such devices can be said to be networked together when one device is able to exchange information with the other device, whether or not they have a direct connection to each other. Computer networks differ in the transmission media used to carry their signals, the communications protocols to organize network traffic, the network size, topology, and organizational intent. Computer networking may be considered a branch of electrical engineering, telecommunications, computer science, information technology, or computer engineering, since it relies upon the theoretical and practical applications of the related disciplines. A computer network facilitates interpersonal communications, allowing users to communicate efficiently and easily via various means such as email, instant messaging, chat rooms, telephone, video telephone calls, and video conferencing. Providing access to information on shared storage devices is an important feature of many networks. There are many different types of network applications. First and foremost is the Internet, the largest network of networks in the world. Second, there are our phones, the oldest of which is POTS, that is, plain old telephone service, which has been replaced by the newer technology, that is the mobile phones. Coming to the network topology. Network topology is how different nodes in a network are connected to each other and how they communicate. The five most common topologies are mesh topology, star topology, bus topology, ring topology, and tree topology. In a mesh topology, devices are connected with many excessive interconnections between network modes. In a star topology, the devices are connected to a central computer and the nodes communicate across the network by passing data through the hub, which is the central computer. In a bus topology, it connects all devices on a local area network called LAN. In a ring topology, it consists of a local area network whose topology is a ring. The message travels around the ring. In a tree topology, it is considered a hybrid topology that combines characteristics of the bus and star topologies. Now, let us talk about network architecture. Network architecture is the layout of the network. Two main types of network architectures are server-based or client-server networks and peer-to-peer networks. Server-based networks consist of clients and servers. Servers are powerful computers that are able to transfer data and information among personal computers within the local network or even to other computers across the internet. A peer-to-peer network is a network that doesn't utilize a central server. Instead, each computer or peer within a peer-to-peer network allows itself to use some of its resources to share with the entire network. Now, network size. Network sizes are defined by a few three-letter acronyms, that is PANs, LANs, MANs and WANs. Personal area networks, that's PANs, are networks that connect an individual's devices such as Bluetooth, headsets and speakers. Local area networks, that is LANs, are networks that are used within larger area such as corporate buildings but can also be used in hospitals or even college campuses. A metropolitan area network, that's MAN, is used to connect computers within cities. Lastly, a wide area network, that is WAN, is a network that contains numerous LANs and is able to connect computers across continents. The largest wide area network is the Internet. Now, network cabling. Cable is the medium through which information usually moves from one network device to another. There are several types of cables which are commonly used with LANs. In some cases, a network will utilize only one type of cable. Other networks will use a variety of cable types. The type of cable chosen for a network is related to the network's topology, protocol and size. Now, let us try to learn about the concept of computer and computer programs. A computer is a programmable machine designed to perform arithmetic and logical operations automatically and sequentially on the input given by the user and gives the desired output after processing. Computer components are divided into two major categories, namely hardware and software. Hardware is the machine itself and its connected devices such as monitor, keyboard, mouse, etc. Software are the set of programs that make use of hardware for performing various functions. The characteristics of computers that have made them so powerful and universally useful are speed, accuracy, diligence, versatility, and storage capacity. Computers work at an incredible speed. A powerful computer is capable of performing about 3 to 4 million simple instructions per second. In addition to being fast, computers are also accurate. Errors that may occur can almost always be attributed to human error. Unlike human beings, computers are highly consistent. A computer system consists of mainly 4 basic units, namely input unit, storage unit, central processing unit, and output unit. Central processing unit further includes arithmetic logic unit and control unit. A computer performs 5 major operations or functions irrespective of its size and make. These are: number first, it accepts data or instructions as input. Number second, it stores data and instructions. Number third, it processes data as per the instructions. Number 4, it controls all operations inside a computer, and finally, it gives results in the form of output. In computing, a program is a specific set of ordered operations for a computer to perform. In the modern computer that John von Neumann outlined in 1945, the program contains a one-at-a-time sequence of instructions that the computer follows. Typically, the program is put into a storage area accessible to the computer. The computer gets one instruction and performs it and then gets the next instruction. In other words, a computer program is a collection of instructions that performs a specific task when executed by a computer. A computer requires programs to function and typically executes the program's instructions in a central processing unit. A computer program is usually written by a computer programmer in a programming language. From the program in its human-readable form of source code, a compiler can derive machine code, a form consisting of instructions that the computer can directly execute. Alternatively, a computer program may be executed with the aid of an interpreter. A part of a computer program that performs a well-defined task is known as an algorithm. A collection of computer programs, libraries, and related data are referred to as software. Computer programs may be categorized along functional lines such as application software or system software. An operating system is a computer program that acts as an intermediary between a user of a computer and the computer hardware. Various types of concepts in computer programming are: number first is algorithm. A set of steps for carrying out a specific task. Algorithms are used extensively in computer programming to arrive at a solution for a problem. The process of creating an algorithm involves documenting all the necessary steps needed to arrive at the solution and how to perform each step. Number second is the source code. The actual text used to write the instructions for a computer program. This text is then translated into something meaningful the computer can understand. Number third is the compiler, a software tool that translates source code into data that the computer can understand. Specifically, a compiler is used to turn source code into object code. The object code is then passed through a program called a linker, which turns it into an executable program. Number four is the data type, which is the classification of pieces of information in a program. The amount of different data types varies between languages. Typically, there are data types for integers, that is whole numbers, floating point numbers, that's numbers with a decimal part, and single characters. To distinguish between different data types, a computer uses special internal codes. Number fifth is the variable, which means a container which represents a value in a program. Variables can store different types of data, including numeric values, single characters, and text strings. The value of a variable can change all throughout a program. Number six is the constant, which means the same thing as a variable with one major difference, that is, the value of a constant does not change while the value of a variable can change all throughout a program. Number seven is the conditional, which is a set of code that will execute only if a certain condition is true. Conditionals are used to test expressions and perform certain operations accordingly. Number 8 is the array, which is a special type of variable used in many programming and web languages, including PHP, JavaScript, and Java, that contains a list of related values. For example, a color array would contain a list of colors. Number 9 is the loop, which is a segment of code that executes repeatedly based on a certain condition. Loops are used to perform tasks repeatedly a certain amount of times. Number 10 is the function, which is a set of code used to carry out specific tasks. A function can take parameters which will affect its output as well as return values. Functions prevent unnecessary redundancy because you can use them as much as needed instead of retyping some codes over and over. Number 11th is the class, which is a template for a real-world object to be used in a program. Classes are used in object-oriented programming. Now coming to the concept of Internet. The Internet was the result of some visionary thinking by people in the early 1960s who saw great potential value in allowing computers to share information on research and development in scientific and military fields. J.C.R. Licklider of MIT first proposed a global network of computers in 1962 and moved over to the Defense Advanced Research Projects Agency, that is DARPA, in late 1962 to head the work to develop it. Leonard Kleinrock of MIT and later UCLA developed the theory of packet switching, which was to form the basis of Internet connections. Roberts moved over to DARPA in 1966 and developed his plan for ARPANET. The Internet, then known as ARPANET, was brought online in 1969 under a contract led by the renamed Advanced Research Project Agency, that is ARPA, which initially connected 4 major computers at universities in the southwestern US. The Internet is the global system of interconnected computer networks that use the Internet Protocol Suite, that is TCP/IP, to link billions of devices worldwide. It is a network of networks that consists of millions of private, public, academic, business, and government networks of local to global scope, linked by a broad array of electronic, wireless, and optical networking technologies. The Internet carries an extensive range of information resources and services such as the interlinked hypertext documents and applications of the World Wide Web, that is www, electronic mail, telephony, and peer-to-peer networks for file sharing. Now, the World Wide Web. The World Wide Web, that is www, is an open source information space where documents and other web resources are identified by URLs interlinked by hypertext links and can be accessed via the Internet. It has become known simply as the web. The World Wide Web was central to the development of the information age and is the primary tool billions of people use to interact on the Internet. The World Wide Web was invented by English scientist Tim Berners-Lee in 1989. He wrote the first web browser in 1990 while employed at CERN in Switzerland. Web pages are primarily text documents formatted and annotated with hypertext markup language, that is HTML. Multiple web pages with a common theme, a common domain name, or both may be called a website. Now, let us try to learn about the browsers. A web browser is a software application for retrieving, presenting, and traversing information resources on the World Wide Web. An information resource is identified by a Uniform Resource Identifier, that is URI, and may be a web page, image, video, or other piece of content. Hyperlinks present in the resources enable users easily to navigate their browsers to related resources. A web browser can also be defined as an application software or program designed to enable users to access, retrieve, and view documents and other resources on the Internet. Precursors to the web browser emerged in the form of hyperlinked applications during the mid and late 1980s, and following these, Tim Berners-Lee is credited with developing in 1990 both the first web server and the first web browser, called World Wide Web and later renamed Nexus. Today, the major web browsers are Firefox, Internet Explorer, Google Chrome, Opera, and Safari. Now, we will try to have a look at EMBnet. EMBnet was established in 1988 as an initiative of the European Molecular Biology Laboratory, that is EMBL. The European Molecular Biology Network, that is EMBnet, is an international scientific network and interest group that aims to enhance bioinformatics services by bringing together bioinformatics expertise and capacities. The main task of most EMBnet nodes is to provide their national scientific community with access to bioinformatics data banks, specialized software, and sufficient computing resources and expertise. EMBnet is also working in the fields of bioinformatics, training, and software development. Examples of software created by EMBnet members are Emboss, Wamboss, Utopia, etc. EMBnet represents a wide user group and works closely together with the database producers such as EMBL's European Bioinformatics Institute, that's EBI, the Swiss Institute of Bioinformatics, that is Swissprot, the Munich Information Center for Protein Sequences, that's MIPS, in order to provide a uniform coverage of services throughout Europe. Since its creation in 1988, EMBnet has evolved from an informal network of individuals in charge of maintaining biological databases into the only worldwide organization bringing bioinformatics professionals to work together to serve the expanding field of genetics and molecular biology. Now, SRS. A software requirement specification, that is SRS, is a document that captures complete description about how the system is expected to perform. It is usually signed off at the end of requirements engineering phase. In other words, a software requirements specification, that is SRS, is a description of a software system to be developed, laying out functional and non-functional requirements, and may include a set of used cases that describe interactions the users will have with the software. Software requirement specification establishes the basis for an agreement between customers and contractors or suppliers on what the software product is to do as well as what it is not expected to do. Software requirement specification permits a rigorous assessment of requirements before design can begin and reduces later redesign. And SRS minimizes the time and effort required by developers to achieve desired goals and also minimizes the development cost. A good SRS defines how an application will interact with the system hardware, other programs, and human users in a wide variety of real-world situations. Parameters such as operating speed, response time, availability, portability, maintainability, footprint, security, and speed of recovery from adverse events are evaluated. Methods of defining an SRS are described by the IEEE, that is, Institute of Electrical and Electronic Engineers specification. Now, NCBI. The National Center for Biotechnology Information, that is NCBI, is part of the United States National Library of Medicine, that is NLM, a branch of the National Institutes of Health. The NCBI houses a series of databases relevant to biotechnology and biomedicine and an important resource for bioinformatics tools and services. Major databases include GenBank for DNA sequences and PubMed, a bibliographic database for the biomedical literature. Other databases include the NCBI Epigenomics database. All these databases are available online through the Entrance search engine. NCBI is directed by David Lippman, one of the original authors of the BLAST sequence alignment program and a widely respected figure in bioinformatics. NCBI has had responsibility for making available the GenBank DNA sequence database since 1992. The NCBI assigns a unique identifier, that is taxonomy ID number, to each species of organism. The NCBI has software tools that are available by www browsing or by FTP. For example, BLAST is a sequence similarity searching program. BLAST can do sequence comparisons against the GenBank DNA database in less than 15 seconds. Next is the HTTP. HTTP, that is Hypertext Transfer Protocol, is the set of rules for transferring files, that is text, graphic, images, sound, video, and other multimedia files on the World Wide Web. It provides a standard for web browsers and servers to communicate. The definition of HTTP is a technical specification of a network protocol that software must implement. As soon as a web user opens a web browser, the user is indirectly making use of HTTP. HTTP is an application protocol that runs on the top of the TCP/IP suite of protocols, the foundation protocols for the Internet. HTTP concepts include the idea that files can contain references to other files whose selection will elicit additional transfer requests. Any web server machine contains, in addition to the web page files it can serve, an HTTP domain, a program that is designed to wait for HTTP requests and handle them when they arrive. Your web browser is an HTTP client sending requests to server machines. When the user enters file requests by either opening a web file or clicking on a hypertext link, the browser builds an HTTP request and sends it to the Internet Protocol address, that is IP address indicated by the URL. The HTTP domain in the destination server machine receives the request and sends back the requested file or files associated with the request. HTTP is called a stateless protocol because each command is executed independently without any knowledge of the commands that came before it. This is the main reason that it is difficult to implement websites that react intelligently to user input. This shortcoming of HTTP is being addressed in a number of new technologies including ActiveX, Java, JavaScript, and cookies. Now let us try to learn about HTML. Hypertext Markup Language, commonly referred to as HTML, is the standard markup language used to create web pages. Along with CSS and JavaScript, HTML is a cornerstone technology used by most websites to create visually engaging web pages, user interfaces for web applications, and user interfaces for many mobile applications. Web browsers can read HTML files and render them into visible or audible web pages. HTML describes the structure of a website semantically along with cues for presentation, making it a markup language rather than a programming language. HTML elements form the building blocks of all websites. HTML allows images and objects to be embedded and can be used to create interactive forms. It provides a means to create structured documents by denoting structural semantics for texts such as headings, paragraphs, lists, links, quotes, and other items. The language is written in the form of HTML elements consisting of tags enclosed in angle brackets. Browsers do not display the HTML tags and scripts but use them to interpret the contents of the page. Now, URLs. A URL, that is a Uniform Resource Locator, previously called as Universal Resource Locator, is a unique address for a file that is accessible on the internet. A common way to get to a website is to enter the URL of its home page file in your web browser's address line. However, any file within that website can also be specified with a URL. Such a file might be any web, that is HTML page, other than the home page, an image file, or a program such as a Common Gateway Interface application or Java applet. The URL contains the name of the protocol to be used to access the file resource, a domain name that identifies a specific computer on the internet, and a path name that is a hierarchical description that specifies the location of a file in that computer. URL is an acronym for Uniform Resource Locator and is reference, that is an address to a resource on the internet. A URL is also known as a web address. A URL has two main components. The first part of the URL is called a protocol identifier and it indicates what protocol to use, and the second part is called a resource name and it specifies the IP address or the domain name where the resource is located. The protocol identifier and the resource name are separated by a colon and two forward slashes. For example, for the URL http://example.com, the protocol identifier is http and the resource name is example.com. That's all about today's lecture. Hope you have understood it well. Thank you and goodbye.